All right. I think we've got Anand online now. Perfect. Waiting. Tata Mobility. Yes, there he is. Anand, good evening. Good evening.
Hi,
Glad to have you with us.
good evening,
Hi, how
Bert.
are you?
I'm good. How are you?
How's all good? All good. How's the lockdown treating you guys?
Well, lockdown has been busier than usual.
Yeah, but we're both in the same state.
Has
Of
been
course,
busier
one
than
in Bombay,
usual.
one in Pune, and two of the most affected cities with the virus. Yeah.
Yeah, that
I'm
is
not going to
correct.
waste much time. Anyways, we've got an hour with us. We've got plenty of time to go through this conversation.
Sure.
Once again, guys, let me just quickly introduce our guest today. We've got Anand Kulkarni with us. Anand's been with Tata Motors for several years. I've known him for well over a decade at Tata Motors, for that matter. And he's been involved with R&D at Tata Motors, worked on several cars that Tata Motors has presented to us in the past and even now. Over the last few years, he's been quite involved in depth with electric vehicles, the whole electric vehicle business at Tata Motors. Anand currently is the vehicle line director and the product line for the electric vehicle business at Tata Motors. Thank you, Anand, for joining us this evening. Uh,
Thank
the
you, Bert.
intent of this conversation, the intent of this conversation, as I mentioned earlier, you guys, is to know a lot more about electric vehicles in general uh, and the whole universe around them. So please feel free to post your questions as this conversation carries on, and let's know more about this. Let's see where this leads us. I'm going to start off. Let's get straight to the crux of the matter. Anand, I'm going to start off with durability,
Mm-hmm.
endurance of electric vehicles, batteries for that matter.
Sure.
My first question is, what is the life of an electric vehicle? In principle, can an electric vehicle be used for perpetuity? Just swap the batteries or change the motor at some point in time and carry on using that car for, I don't know, decade, 2 decades, 3 decades, 4 decades, even longer?
So, Bert, this particular question is not a simple question, as you know, because it will depend on the kind of chemistries that you are deploying. It will depend on the sizes of the battery pack, the operating conditions, and the pack configurations. Now, let me try and detail this out a little bit. So, to the question that how long can batteries work, let me toss that question back again and say, what would affect a lithium-ion battery life? And the moment we have addressed those questions, then it becomes relatively easy for us to say, if we were to take care of these factors, then we could have a much longer life of batteries. So you see, lithium-ion batteries are the chemical entities, and therefore they are sensitive to high temperatures. They are sensitive to high charging rates. They are sensitive to high depths of discharges, and also if you overcharge them or high voltages. Now, what happens is on an electric vehicle, we already have multiple levels of checks, super checks through the BMS or through other strategies in order to make sure that the car does not or the battery does not experience these kind of conditions. However, having said that, if you are going to subject your batteries to these kind of conditions, then the life of the battery is going to go down faster. Now, when we say that the car has come to a point where the battery would need to be replaced, typically today in the automotive world, people are talking about 80% residual life or a little bit lesser. Some people are talking about 75. Some people are experimenting with 70%. But at that point of time, people say that you would need to replace the battery. Now let's understand how long will it take for us to get to that point. And I want to draw a parallel with the cell phones that we all are very, very comfortable with and familiar with. Every cell phone battery has a typical battery life. And we see that after about 2.5 years time, the performance on the batteries go down. We need to charge them more frequently. Something similar happens, but you can imagine that the EV battery is significantly larger, and therefore you will probably start seeing the deterioration in terms of the range that you got at the beginning of the car's life and the range that you would get after a certain number of usage. But theoretically, if there is a customer who's okay with doing this kind of usage, and he's okay with a reduced range, and two, reduced performance, then the warranty can extend, the life of the batteries can extend significantly. Now, if you look at what manufacturers are doing today, including Tata Motors, uh, 8 years is sort of the standard now for the warranty on the battery. But going beyond, actually the battery will last significantly longer. Now, the question of perpetuity, you used a very nice word, perpetuity. In automotive terms, the perpetuity is probably about 15 years, 17 years, because beyond that, you would have a lot of mechanical failures as well, which you would probably not want the vehicle to keep going. Having said that, there are enough number of first generation EVs, like the Nissan Leaf, for example, which is now, as you
Yes.
know, sold about 400,000 units worldwide. But there are still the first generation EVs which are still going on the roads, and they are anywhere between 10 years to 11 years, and they're still going. So in that sense, I think it is appropriate to say that yes, with a certain level of compromise in performance and the range, you could actually run your batteries for a significantly long period of time.
All right. All right. I'm just gonna diverge over here for a second because there was a very interesting question that came up. I just noticed it on the feed. And before we lose, let me ask you this: we're in a lockdown period. I have got an electric vehicle. What's the kind of maintenance that I require for an electric vehicle at this point in time? My batteries would discharge. Am I going to be in trouble? Is there going to be something that I need to take care extraordinarily for EVs at this point in time? Like for an
Uh,
IC engine, we tell them, go down every 5 days, 10 days, crank your engine, things like that.
So I'm going to split this question between the mechanical part of the car and the electrical part of the car. So let's understand that the mechanical part of the car, you will have to do the same thing that you would have done on a ICE engine. So for example, if you've put on your handbrake while you park the car to begin with, it might be a good idea to go back and operate it so that the moisture and the other conditions don't sort of lock the brake in, and you do
Yes.
not have a sudden failure when you start the car back after 4 6 weeks of lockdown. But having said that, the question is probably more relevant to electric vehicles. So let me say this, that the battery per se does not deteriorate, run down, or misbehave. Uh, However, there is always an auxiliary battery, the auxiliary battery which powers the 12-volt architecture. And this 12-volt architecture can sometimes, at all times, they can have a certain amount of leakage current because there is certain things which are running in the background. Typically, the remote opening understanding of the car and so on and so forth. So there is a possibility that the auxiliary battery might have a problem, and while you can always make sure that the main battery feeds the auxiliary battery, it is a better thing to make sure that the terminals on the aux battery are taken off if the car is going to be stopped for a long period of time. Otherwise, from an electrical vehicle perspective, I don't think there is any other precaution that needs to be taken. One thing though, we would always also advise that you should not leave the car connected into the charging socket and leave it on, because sometimes it can be prone to a little bit of voltage fluctuations, and we don't want those errors to, while the car is protected, we don't want any errors to pop up on the screen also.
All right. Also, another question, and this is also because this would apply normally as well. My car is, let's say, parked outside now for a long duration of time. It's parked out in the sun and not really gone down. It's not covered parking for that matter. It's out in the open. There's a lot of heat buildup. We're entering the summer months as well. So the heat buildup inside a cabin is substantial. Temperatures can go up to about 55, 60 degrees as well. So it's inside a cabin. That will also affect the floor pan and eventually the battery pack as well. Will this have any adverse effect on a battery pack? Temperatures right now, where they are.
So, but we need to understand that the cars which have a IP67 battery, IP67 sealed battery, uh, they also typically have a thermal layer between the battery and the floor, as well as between the battery and the top. And therefore, typically the temperature inside the batteries or inside the battery casing can be a good 10 to 12 degrees lower as compared to what your ambient is. Also, the peak temperatures in a day tend to be between about 2 o'clock to 4 o'clock. and
Yes.
beyond that it cools down. The battery is not exposed to direct sunlight, therefore the battery can maintain itself at a reasonable temperature.
All right. Coming back to the order that I had decided. Now, the deterioration in charge, depending on geography,
Ah.
does it get affected by humidity, by being close to the sea, for instance? Because salt in the air, could it affect the electrodes? Could it affect the points, the securing points? All of these. Also, altitude, temperature, all these variances. How do they affect battery life? Today, if I had to live, for instance, as an example, if I had to live somewhere in Himachal at a higher altitude, is it feasible for me to own an electric vehicle without the, in a stressful environment, a stress-free environment? Is there something that I need to worry about or be careful about? Can it operate? Can an electric vehicle in the higher altitudes operate as freely as it would do in the plains?
That's a very good question, because let's look at the atmospheric conditions that will exist, and I think this also comes back from our experiences of having used IC engines, where when we start ascending, we find that there is a drop in performance. Then we start to look at smoke coming out and so on and so forth. So there is a different way in which the car reacts. So in case of an electric vehicle, let's understand this, that it has no understanding about or relationship about humidity, or for that matter, altitude. It does not, there is no altitude compensation that is required. It's all electrical energy. However, what can often happen is when you go to higher heights, because of the temperature being lower, you might be required to bring in the battery heating system, and that might consume a slightly higher amount of charge than you would normally do on the planes. And but in terms of or a comparison with the ICE engine, there is no altitude compensation from performance, life, or from a range perspective that happens on electric batteries. If you are on the hills, then because of the fact that you have to drive
Like,
up gradients, climb up gradients, you might expend a larger or a higher amount of electricity. But
yes.
by itself, it does not mean anything different over what it would have
Atmospheric
done.
pressure.
No, 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 it
Atmospheric
doesn't.
pressure would not affect.
Yeah, yeah.
Okay.
There is
What
one system. There is one system though that we have to be careful about, and that's what we would all do calibrations and checks and balances. So while we have no problem or no effect of altitude on the electrical system itself, the braking system, which could be vacuum generated, could have an altitude related effect, and that's where setting of the vacuum pump or setting of the booster, if it is a booster enabled brake system, is something that as development engineers we tend to look at that and make sure that there is no problem.
But which is a standard setup for even IC engines or EVs. That is a regular
Correct.
mechanical feature in any case.
Absolutely.
So
Absolutely.
as an EV, there is nothing extraordinary that atmospheric pressure will bring to it.
So in fact, I would go to the extent of saying that electric vehicles will give you exactly the same performance on the planes as they would do at altitude, and therefore that's one leg up for the EVs.
Super. What about salt, especially at the coastal regions? Does that affect electrodes and things like that? Because we've seen this in electronics, where the moisture in the air and the kind of moisture also, because it's salt laden in Bombay or Chennai or some of these cities along the coastline. Can that affect EVs?
So if you have a IP67 sealed battery, you're not having any moisture get in, and therefore all your terminals, all your connectors, all your high voltage architecture inside is protected. And if you have therefore sealed it properly, then there's no such issue within the battery. Uh,
But
you could
inside it,
always,
motors.
sorry.
With the motors.
Yeah, so outside of the battery, let's look at what happens to connectors. So again, the connectors of critical components of the high voltage architecture are always IP67 sealed. So you do not have moisture go through. And as a result of that, you cannot have, I mean, you do not have passivation, or you do not have these kind of effects. So
All right.
in a way,
Okay.
it is fairly secure.
Okay. Okay. Uh, When we come to safety while charging, uh, can electric vehicle batteries be overcharged? Like it happens on a cell phone battery. sometimes overcharging the batteries can explode, they puff up, excessive heat, sometimes smoke as well. You've seen there's been an issue with a lot of smartphone, for instance, is not being allowed on flight, battery packs and things like that, not in the hold. But is that an issue with the EVs as well? Can something of this sort does something of this sort exist?
So theoretically, a battery could get overcharged, but then, as I said earlier, also, and I want to repeat that the battery management system, the BMS, is essentially maintained on the car in order to prevent these kind of occurrences. Because, as I said, out of the four factors that we spoke earlier, overcharging of the batteries is one of the things that leads to a sudden or rapid drop in life of the battery. Therefore, from that reason, also, we want to make sure that we do not have overcharging. Typically what happens is even if you were so let's look at two types of charging. You do slow charging and you do fast charging. So in slow charging, you are anyway restricting the amount of current that goes into the batteries. But even in fast charging always happens only up to 80% of the capacity. Beyond 80% of the capacity, it starts to gradually trickle down to a point where at 99% you are absolutely sending in a trickle. And after that also, if the car does not get unplugged out of the charger, then the entire thing will stop. So there are checks and balances. There are redundant systems also built in order to make sure that at no time you overcharge the batteries.
All right. Okay. You're talking about fast charging and slow charging. Within this, also, is it safe for batteries to be consistently fast charged, or from time to time should we do the trickle charging as well, just to ensure that the longevity of a battery is longer? Does either of the charging methods deteriorate battery life?
So modern day batteries are more sort of, I would say, resistant to significant effects of fast charging. But however, having said that, we recommend that even if you are a user who wants to charge always at fast rates, both from a battery life perspective as well as from the ability to extract performance from the vehicle, you need to do slow charging at certain point of time. We advise that at least once in 15 days you should do a slow charging. And look at it, the reason being, when you fast charge, you are pushing in a lot of current through in a very short period of time. The way that the entire battery behaves, or the way that the entire battery pack charges itself, is when all the cells go up properly to their desired levels. Because one of the checks on the battery management system is that if it finds that there are two cells which are showing a abnormally different level of voltages, then it sees that as an error. And the more that you fast charge batteries, the more you would get into issues where these differences can exist higher, and then it could kick in some protective measures from the BMS. So it is always better to re-establish this equilibrium, bring all the cells back, and a slow charging helps you do that. So it's again similar to what we do on the cell phones. I mean, these days a lot of cell phones come with fast charging. These are to be used as measures to be done when you really have an emergency, you need it. But if you try and do this again and again, there will be safety procedures that will kick in. But then it would also impact the life of the battery eventually.
Which interestingly is something a lot of cell phone manufacturers don't inform us about, because they give you a fast charging unit and that's what you use for the rest of your life.
Correct.
Which,
Correct.
like you point out, is not one of the best ways to go ahead with.
Yeah.
Coming up to the next question, a lot of people have this also here, water logging and, in case of accidents, flooding, is the battery safe enough? But I wanted to ask you another question. In a thunderstorm, uh,
Yeah.
freak incident of nature, your car gets hit by a bolt of lightning. What happens to a battery in that case? Is
No, so I want to actually say that you might be in a better situation if you're in a car, if there is a lightning that is going to strike you. And this is so for ICE, or this is so for EVs as well. Because just see what happens when a bolt of lightning hits you. It hits the external surface of the metallic external surface of the car, and then because of the electromagnetic effects on the skin of the vehicle, it actually drains down safely into the ground, the Faraday's cage. Yeah.
yes,
So you are actually better off by sitting inside the car. And so if all of that charge is going to pass down safely into the ground, then nothing much is going to happen. Now the question is, what happens to my battery? Because I'm sitting already on an electrical system, will somehow these two electrical systems interact with each other and that will cause a problem to me? The answer is thankfully no. You wouldn't be in any kind of difficulty. In some cases, depending upon how the lightning strikes, you could have a few error messages pop up, but nothing that would lead to bodily harm or any other problem for people. And in fact, the NHTSA
Yeah.
came out with a report in 2017, which I want to refer to you, where they've compared exactly the same kind of behavior as to what happens to electric vehicles in case of a lightning strike. And it said that electric vehicles are by no mean at a higher propensity as compared to their ICE siblings. In fact, they are comparatively lesser prone to any damages on account of electric or lightning strikes.
Yeah, well, City Tourer was hoping for a free charge. Unfortunately, that is not going to happen. But moving on, another doubt a lot of people have, and they hear this often enough, is that because battery packs emit a lot of radiation, in the case of an EV, you are sitting on a fairly large battery pack. Is this radiation free? Does it not emit radiation? Or is there a layer or a lining that prevents that radiation from permeating into the cabin?
So all electric devices, irrespective of whether it is a battery that we use on the car or any other electrical component, even in the regular IC engine, they have something called as EMI, EMC. And there are standard regulations as to how much EMI, EMC should a person be exposed to. And by the way, the norms on the electric cars are no different than the norms on IC engine cars. And therefore, each of the cars that would hit the roads today would have to undergo the certification for roadworthiness of the EMI EMC. You could probably talk about this interference in terms of the minutest of these variations could manifest themselves in either in terms of radio disturbances, radio frequency disturbance, or your cell phone network. And
Yes.
Therefore, we do not have any of these disturbances, which is again indirect proof of saying that you do not have too much of EMI EMC, and therefore they are absolutely okay bird.
Correct. We've come, a lot of, I kept throwing up these terms, IP65, 67, all of these. Can you just tell people what exactly is IP65, 67? These are industry standards for dust and water permeating into the battery pack. Can you just elaborate on what those are, let people understand what it is as well?
Sure. So IP stands for ingress protection, and the two next two digits stand for dust and for water. So higher the number, the better is the protection against these two elements. Typically IP67 is something where you could actually submerge that component into water of up to a meter height and stay that way without any problems for up to a half an hour situation, and you would not have even a single drop leak past. You could have IP65, which then becomes a little bit more lenient as compared to IP67. But anything beyond IP67 would start to really be a overkill, because then you are looking at submergence of up to about 5, 6, 10 meters, and so, which really is not the case that an EV, or for that matter any other vehicle, would need to go unless somebody pushed the vehicle into a pool of water or something.
Well, would it make sense in an SUV, for instance, something that would go 4x4? You might want to ford a river somewhere, you get stuck, you want to make sure in the future that, you're in a situation where you can actually get yourself out of that situation.
So typically IP67 is seen to take care of everything, because you see the battery itself sits at a certain height from the ground, and then over and above that you are protected for about a meter, which typically would take to the roof line of the vehicle. And I mean, at that point people would want to get out of the car, unless it is for a very short duration, which extreme sports does, sometimes.
I have seen some extremely adventurous people put their vehicles into some extraordinary situations.
Yeah. So for a very short, brief time, it is okay, but that does not trouble the car.
All right. One last question on the durability farm. What can I do with my battery once it comes up for replacement? Does that battery belong to me as the owner of the car, or to the company, to the organization? Are there any laws in India identifying how they have to be disposed?
So the battery belongs to you. You've purchased the battery right up front. There are some other people in the industry elsewhere, not in our country, working with a battery that is actually given to you on a lease. But right now, for all practical purposes, the battery is yours. You decide. You can whatever you need to do with it. When it comes up for change, let's say in the unlikely event that it does come up for a change, it is possible to repurpose the batteries. There are a lot of people who are now coming up who do repurposing of the batteries, which means they tear open the batteries and then they can remove each of the cells and they can use it in various things. There are some very good startups across the world who are doing this as a matter of trying to take electricity to some remote locations in Africa and doing it as CSR activity. There are norms within the country. India is also trying to establish the norms as to how the battery should be repurposed or how the battery should be disposed of. That's still work in progress, Bert.
All right. I'm going to move on from durability to charging infrastructure, the environment around that. Um, let's talk about the batteries in a car right now. An EV has two sets of batteries. One is used for propulsion. The other is your auxiliary battery, which is used for all other functions inside a car, your air conditioning, your lights, your sound system, power window, central locking, whatever it is. What is the relationship between these two batteries? Because in an IC engine, from what we understand is, we've got the IC engine also through the. This is something you do not have or you do have in an EV as well. How does it work?
Bert, I lost you in the middle in the last portion. I understood. So if you could please repeat that for me.
So as I was saying, the EV has got two batteries. There is the main battery which is used for propulsion, the lithium-ion battery. There's an auxiliary battery which could be a lead-acid battery that is used for all the electrical systems. Now, in an IC engine, the main engine through an alternator charges the battery. But
Correct.
in an EV, how does that function? Because there isn't, you're effectively drawing power from the source of power, it's the same thing as a battery.
Yeah.
Is depletion higher, lower, or non-existent? How does it work? What is the relationship like?
Right. So the analogy to the alternator. The alternator is the device, machine, electrical machine, which uses which is coupled to the crankshaft of the ICE engine, and that drives the motors inside to create the energy. So the alternator is what creates the energy and feeds into the main battery.
Yes.
In case of an EV, since we do not have an alternator, but we have the DC-DC converter, which will step down the energy which is available from the main battery and feed into the auxiliary battery at 12, 13, 13 and a half volts, whatever the case might be. So there are set points which have been identified. And whenever, this could be a matter of strategy because a lot of people do different things depending upon what kind of battery gets used. In many places, people use lead acid batteries, but there is also a possibility of people using lithium-ion batteries even for the auxiliary battery, because then it gives them higher depth of discharge as compared to a lead acid battery. The only problem with using a lithium-ion battery is that it has to be placed inside of the vehicle. It cannot be placed inside the bonnet because it then becomes temperature sensitive. But having said that, you use the DC-DC converter to step down the voltage and feed your auxiliary battery at all times, and the amount of charge that gets consumed is exactly similar. In fact, I would say that if you would relate it back to how much amount of fuel do you burn in order to get to the level of energy that you need, electrical vehicles tend to be significantly more efficient because back of the envelope calculations now, you have a situation where the IC engine burns fuel and only 30% of that is converted into mechanical power. Out of that 30% mechanical power, you are picking up energy by the alternator, which itself is only a 50% efficient machine, 60% efficient machine. So you've got only 15 units of power, and that's what is getting into the battery. Against that, you have almost 100% energy getting into main battery of the EV.
Yeah. Okay. Okay. So, which is interesting to know. I mean, this is something that a lot of people don't understand and don't seem to realize. But however, there is some amount of depletion of the main battery that will happen in this case compared to an
Always.
IC engine, for instance. Yeah.
Yes.
All right. How does how does an individual manage charging an EV? What should the pattern be? Is there a set pattern? Should we look at something of that sort? You know, we want higher longevity for a battery. We want it to go on for a long period of time. We want to manage the amount of charge that is there in the battery. Are there studied patterns to this? Advices that manufacturers give out to customers saying this is what you need to do.
So what people do advise is that try to do as much slow charging as possible where possible. Not that it is necessary, but obviously that improves the longevity of the batteries. The second one is don't try to discharge the batteries very deep. I mean, you start at 100%, don't go down to 5%. You may want to, if you are in a situation which allows you to do that, start recharging at around 30%, 35%. I mean, of course, the range is always available, but you don't want to just extend it because you can increase the life. In fact, if you don't pull down or deep discharge, then you might have a better life. Otherwise, I think there is no other advice.
Right. And I live in a society, for instance, a large society. Supposing I live in a large society, hundreds of families, and space is a constraint. What kind of a charger can I, what ideally should be the charger that I use at home? How do I distribute this? I may even want a fast charger
Yeah, so
or the slow charger.
this is a very important question that you have, Bert, because there are some issues about how people are tending to treat this, and I would have also picked up exactly the same situation, same use case that you are talking about right now, where you have huge societies, high rises with lesser parking space, and sometimes people may not have their parking space exactly below the place that they live. They may be a little distant. What do they do?
Yes.
So this is something where a paradigm shift needs to come in, and people need to start saying that we would want our society to install a fast charger. And I think what we would suggest, what we would and I would insert this question for a thought, is that let's try and look at these chargers as an amenity. Uh, because if you look at it as an amenity which is for the common good of the community, then it will have significantly more benefits to all the people involved. Otherwise, you see, what is to prevent us from getting into a situation where, 10 years back, definitely, uh, you had all these cables being drawn from one window to another window and the entire terrace being full. You're going to start replicating that kind of thing on the ground because let's say EVs do achieve a significant amount of penetration. Then everybody is going to go into his own meter, tap into his meter and try and take out a connection. There are going to be multiple open points, more situations of error states cropping up. Instead of that, if you use this like an amenity, it's a common resource for everybody. Then it becomes much more cleaner. Safety standards can be established. So that's what we would think all of us need to start thinking about.
Okay. I've got another question on this, but before that, I'm going to take a couple of questions that have just come up on the feed on this over here. There is one from Electric Vehicles Web, and they want to know what are the differences between the Electra AV powertrain used on the Tigor to the Ziptron used on the Nexon. And there's a follow-up to that as well. What advancements would one see on the next immediate Tata Electric cars like the Altroz or the HBX EV as compared to the Nexon EV?
Okay, so while I may not give very clear answers on the second question, because that's
But you
still
first,
something which,
yes.
but I will definitely give you the differences between the two technologies that on the two cars that we have. Please note, however, that when I tell you this answer, it's also got to be looked at from a perspective of each of these cars being used for a specific use case, and therefore let's appreciate why it has been done also. The Tigor EV it uses a low voltage architecture, and the Nexon EV uses a high voltage architecture. Now, if you look at it technically, anything which is below 60 volts is called low voltage. Anything above 60 volts is called high voltage. The Tagore Ev is actually 72 volts. From a technical perspective, it is at a high voltage, but in the real sense, it is not at a high voltage. So these are two big differences. The second thing is the motor which is used on the Nexon is a permanent magnet synchronous motor, which gives you very high efficiency. And by the way, permanent magnet motors also tend to be more available in the high voltage format, and therefore it gives you higher efficiency and higher power as well. The power density on these motors is quite high in a smaller space. Of course, the other thing is the amount of range that we have packed in. So the Tagore EV has two versions. We do a 16.5 kilowatt hour battery, as well as we do a 21.5 kilowatt hour battery. The Nexon has a 30.2 kilowatt hour battery. So these are the salient differences.
Okay. I've got another question for you. A couple more questions over here. In case of an accident, what should be done with the existing battery in case of damage? But I'd like to post that question as a slightly different way. We tend to ignore certain damages sometimes in a car, in an IC engine car. Another car rams us from the behind. Another motorcycle kind of runs into us from behind. Maybe small cosmetic damages that appear, bumper or the door or the fender. But are these to be genuinely? Should we just ignore this? Or is it necessary now to actually go down to a service station, check that the health of the battery, because this is where the battery packs are usually positioned. Is it necessary to go and check and evaluate and see that there is genuinely no damage to that?
We would advise that depending upon the impact that has happened and the severity of the impact, it is advisable to go and have a check at the service station just to make sure that there has been no damage to the internal components. Because we all take protections, we all take precautions to make sure that the batteries are safe, but it's not worth risking anything, and therefore it is always better to go and check. It does not take too long. It's probably a quick check where he will plug in the computer and find out whether everything is working fine or not, and we advise that. Yes.
All right. So I'm going to come back now to what we're talking about, especially with the societies, apartment blocks, people living and installing charging infrastructure for their personal use. And there was a story that we had done about a year ago, which is a fairly interesting story, where certain legislation issues also exist in this case, because societies cannot just allow you to put a charging station in place. The parking may or may not belong to you. But under the bylaws, there are certain rules existing where certain things like chargers, once you position them on the ground and it is registered to your flat, because you're the owner of the flat, it also means that that particular space belongs to you. You are the owner, you're the one who's paying for that or for the usage of that space. So effectively, there is some ownership or owners that comes on to you as well. So there are certain legislative issues also with this. I think this is an area that will take some time to clear out and for things to get streamlined.
Yeah, I agree with you. I agree with you, because although the government has been the government has announced a lot of conditions, a lot of relaxation in terms of what you can do for an electric charger. This is a space that is still evolving, and we will need to look at how it grows, how it matures. I fully agree with you.
All right. Is there even the remote possibility, Anand, of a battery being made that can provide a range of 1,000 kilometers or so? Do batteries or can batteries exist with that kind of energy density? Is that feasible? One. Secondly, is it practical in the long run? We've seen IC engines capable of doing things like that on a single, fuel tank, doing some incredible mileage and incredible range. But is that something foreseeable future? Is there something that could actually be done as a study, or is it possible at all?
So in the technology space, you never say never. But
Exactly.
See, if you look at what's happened in the last 10 years, 10 years back, you had cells which were probably around 120 watt hour per kilogram. Today, you are already within kissing distance of 300 watt hour per kilogram on a regular basis. And there are already technologies which are talking about 400, and there are plans to take you to 500, 550 plus. So in a sense, you are starting to see that higher and higher energy density batteries are coming through. How much range can you package is less of a problem of whether you can package it or not. It is more of a problem of whether people find utility of those batteries or not. And you know, at the time of the Nexon launch, we've discussed this in some measure. So technically, if we were to give a range higher than what people would expect, from a vehicle side, we could manage that. But then, would it be affordable? Would people be able to see the utility of having a large scale battery, or is the condition better to have a reasonably sized battery and have a network of chargers where you can access it quickly? Because whether we like it or not, we don't drive more than 50 or 70, 75 kilometers. Some of us 100 kilometers on a daily basis. We don't drive more than that. I mean, it's a different question between you and me. Perhaps we drive a lot more, but I'm talking about the average person on the as a owner of the car. So technically, it is possible that cars can go to significantly higher ranges. You have all kinds of announcements coming through, people saying that I can do a car that now, last year, people were talking about 500 plus cars. Today, I saw one ad for a new car that is about to come 700 kilometers. So 1,000 is not too far off. It can be done. Whether it should be done, whether there will be people who will take that car at the price point that it will come, that's a different question altogether.
All right. I saw another question over here, which came on the feed. Now, there's what if after 4 years, Nexon EV battery range goes down? Do I get any warranty on that? I think standard that warranty rules will apply for that as well. However, because a battery pack is an electrical system, do the same warranty rules apply in this case, considering the other electrical appliances that are also there in a car and where warranty is much lesser? Headlights sometimes don't carry any warranty at all, for that matter. If it fuses, it could fuse, then you don't get a replacement at all. But do the same laws apply in both instances, or there are different set of rules for each?
There are different set of rules for the regular electrical components on the car, the 12-volt components, and components that are of the electrical architecture. So, for example, we have given the warranty of 1,60,000 kilometers / 8 years on the battery and the motor, the gearbox, and the high voltage electrical architecture. But it would not apply to, for example, the Viper motor, and like you said, for example, the headlamps, tail lamps.
Yeah.
Correct.
Okay. I'm just going through the feed. Are the cables used in Nexon EV capable of withstanding rat bites? I said someone lives in a rat infested area, but it's a valid question.
No,
yes,
it's a valid question. It's a valid question. So we've taken care to make sure that first of all, wires are protected with corrugated covers, and also the wires are routed in such a way that a rat does not find a place to sit or lodge itself in a comfortable position to nibble away at the wires.
All right. I have another interesting question. Can you explain the difference between power density and charge density of the battery? Are they correlated in any way?
So power density is the ability to give power as demanded by the vehicle architecture or by the motors. The charge density is the amount of charge that the batteries can hold. It can be different depending upon what is the configuration of the batteries that you've sorted out or lined up for yourself, and they can be different.
All right. Another question that's come up: has there been any plan to franchise EV charging stations? Also, do you see a market for residual batteries in India?
It is too early to talk about the residual battery market in India at the moment. We are still in very, very early stages. But as I said, second life of the battery, recycling of the battery, which will come up as volumes of vehicles and numbers of vehicles on the streets go up. So that's the situation on that. And what was the first part of the question? Sorry, franchisee on the charging stations?
Yes.
So
this was
franchise.
yeah, go on.
We haven't announced a franchisee per se, but yes, we are tying up with a lot of people such as Chroma stores, such as some other malls to sort of install the fast charging network. This is being done by Tata Power.
So most of these are largely, yes, we are aware of the Tata Power involvement in this, but these are mostly corporate-led initiatives rather than just the government stepping into the space.
Correct.
All right. I'm going to come to the financials and the environment around EVs. This is such an interesting subject. There is just so much to talk about, and I think we're running out of time, but I'm going to quickly run through this nonetheless. Uh,
Okay.
First of all, do we reach a situation where manufacturers will offer different battery sizes in cars so that you can get it for different reasons and purposes? Maybe a more density battery for performance purposes, another for larger range or lesser range, where the prices also will get affected accordingly.
So we have to look at two things, Bert. You may have different capacities of the batteries, but they have to be lined up in such a way that it becomes compatible with the rest of the architecture that you have on the car. Otherwise, it does not suit the purpose. Now, I want to give you an example of the Tagore Ev. The Tagore EV, for example, does a 16.5 kilowatt hour battery on the EESL version that we had done 2 years back, and it now does an extended range version of 21.5 kilowatt hour. So it's already there, therefore. The only thing that I want to tell you is that, for example, it may not be possible for people to say that can I have an 18 kilowatt hour battery? Because then the
Yes,
rearrangement of the batteries, the way that the
exactly.
cells get organized in series and parallel, that will change. So yes, it is possible for people to do that, to sort of create a more uh, uh, why would somebody want to pay more when his use case is not going to be as high, and vice versa? So these
All right.
possibilities can exist. Yes.
All right. Another question, or not question, but actually a statement coming up. There's some lithium sulfur batteries with 2,000-kilometer range per charge entering testing this year. Yes, lithium sulfur is coming up. What are the advancements in battery technology in that sense? Right now, we just know about lithium-ion, which is being used extensively. But going ahead in the future, what are the kind of batteries that we can see coming up in electric vehicles?
So there is a lot of research going on multiple aspects. Some of the space which is looking very interesting is when people are trying to do metal air batteries. So, for example, there have been reports, and I'm sure all of us have seen WhatsApp videos circulating of batteries that can do 1,000 kilometers on a very small format car. Also, they are the aluminum ion batteries or the aluminum air batteries. And there are people who, so by the way, aluminum air batteries tend to be sacrificial batteries. And despite the fact that these batteries can give you a significant amount of range, you also need a buffer lithium ion battery, because a sacrificial battery cannot recover charge. And therefore,
Yeah.
you will need something like a lithium ion battery to do that. The second area that people are all looking at very keenly is solid state batteries, because right now what happens is you have a jelly roll, we call it a jelly roll inside the battery,
Yeah.
where it is a layer of electrolyte as well as then the active materials. Uh, but then people are trying to remove this and made the two components so that it becomes more dense, as well as it becomes less unsafe, so to say. Solid state batteries are supposed to be a breakthrough because they will be more compact. They could give you higher densities as well. So these are some of the areas that people are looking at. Of course, people also try and work out on alternate materials, because cobalt being a strife material, people are trying to find out alternatives to that as well.
All right. Um, think putting up malls, charging stations. Yes, there are lots of practical solutions to putting up charging stations. Malls being some of them, restaurants being some of them, food courts, for instance, along the highways. Lots of people. There are lots of solutions that are coming up where charging stations are concerned. A lot of ideas will come up in the future. Also, we'll see a lot of these developments happening up. I think one of the principal issues at this point in time was who pays for charging or for charging the car. How much do you pay for it? How do you charge for it? On what basis? And all of these things are policy matters, and these will come up in the course of time. There's already, legislation is being passed rather on private enterprises being allowed to charge for power, which you couldn't do previously. But now that's
Hmm.
coming, that's come up as well. And I think it's a matter of time before this falls into place, and we'll see some developments in that area very, very soon.
Right.
And another question I had, Anand, I'm just going to come to that, is at the end of life, it will be 10, 12, 15 years, can I simply replace the batteries and carry on with my car? Or do I have to scrap, if there is scrappage, do I have to scrap the entire vehicle? Also, do scrappage laws in the case of EVs, would they be the same as they are in the case of IC engine cars at this point in time?
You may not need to scrap the entire vehicle. So first of all, I want to tell you that it is very likely, very highly likely that your battery will go on for the life of the vehicle. But let us assume, because you've asked that question, let me assume that there is a possibility that you may have to replace the battery. It is possible to run the rest of the vehicle without any problem. It is possible to change the battery, and the scrappage for there is a problem, or there is something which is still under decision, still things being worked on the recycling of the batteries. But for the rest of the components, I don't think it matters, because it's that way relatively known. It is You will have to take special precautions in terms of electronic parts disposal, but because of the cell phone and other things that we already know of, that's not going to be so much of a difficulty.
Okay, I'm going to take two more questions over here, Anand. I think we won't have much time beyond that, and I want to get into a question, and then the session ends in the middle of all of that. There's a question by Baba Kamte who asks, worst case scenario, a cell burst, how to control fire in such a situation?
First of all, I want to tell you that the cell bursting and things of this sort are a cinematic version of life. It does not happen. I have not seen a car suddenly explode, neither in an IC engine, and let me tell you, it is not going to happen in a electric vehicle either. But having said that, so rather than explode, yeah, the closest that it can get to an explosion is actually a fire. And if you are going to have a fire, you should not douse the fire with water, because that's the last thing that you would want to do. You would need a fire extinguisher, or worst case, you would need sand, soil, whatever you can lay your hands on, which is dry and which will put down the fire. Please don't use water. That is the absolutely the worst way to do it.
Last thing.
Yeah.
Uh, okay, I've got Baba. Baba Gamte, I hope that answers your question. I've got another question from Shaurya here. Is there a greater scope of ADAS on EVs?
Well, I wouldn't see it why, because it should be either way. But let me also tell you that if you were to implement ADAS on an electric vehicle, which is feasible, which is possible, the battery sizes will expand significantly because of the computing power that is required on the ADAS systems. The battery sizes will grow up, and there will be a significant increase in the cost of the vehicle. But I don't see any reason why ADAS should be differently enabled, or applicable to EVs as compared to ICs.
All right, guys. Also, just to bear in mind, we're trying to do a technical conversation over here to understand everything about the world of EVs. Not so much as to what Tata Motors is doing, what their plans are. Anand's expertise is in the region of tech, in the technology space. So it's best that we understand everything about this. I've got one more question. I think we may have time for this. Uh, and that is, I hope you're not running out of time. What advancements can we expect on the next Tata electric cars as compared to the Nexon EV from a technology standpoint? Where are we advancing to? In the Indian space also for that matter, what are the advancements happening in the EV space?
We would want to make sure that the Ziptron platform that we have launched, which is a high voltage architecture with permanent magnet motors, with batteries that are IP67 sealed, continue to go forward. There will be a couple of additional aspects that we might do in terms of incremental benefits for range, or for performance, or for efficiency, and we will come to those. This is actually a product related question, because these changes tend to get accompanied with product, and we will get back to you when we have things to disclose on this.
All right. Anand, I'm going to wind this session up over here. I don't think we have
Okay.
much time, but thank you so much for being with us. That was very enlightening. I do hope all of you people out there who joined us in this conversation learned a lot more about this. Please feel free to send Tata Motors your queries as well, and of course, send them to Overdrive also. Anything that you need to know more on electric vehicles, the infrastructure, the environment, the technology behind them, and if there's any way that we can help you out, we would definitely love to get you that information. So thank you for joining us. Thank you, Anand, for being a part of this conversation, and all the best to you, sir.
Thank you, Bert. And I would only say this has been an excellent experience because we've talked to people while at the same time being extremely safe. So the last thing that I would like to tell people is stay safe, stay secure. Thank you so much for listening to us. Thank you.
Thank you, guys. Stay safe as well. See you. Bye bye.